Hi everybody, Patrick here from EngineeringShock.com, ElectronicLessons.com, and now PaintballProps.com. This is project number 5, our basic light sensor circuit for our multi-project electronics learning board. They are on pre-order right now at EngineeringShock.com and ElectronicLessons.com, which will take you to our eBay store. What this is 4 different blocks. We're going to talk about them in detail, but if you want them in full detail, please look to the tutorials below. There is a tutorial on our voltage dividers / light-dependent resistors, our variable resistor potentiometer. This will give us a variable voltage between our VCC and ground. In this case, our VCC is 5 volts. Our comparator using an LM324 op-amp, and our LED indicator. Now again, these are blocks. We're not going to talk in complete detail about them, but what we're going to do is in a minute, is after I go through this basic tutorial, is we're going to plug this in on the learning board. Now, again, in previous discussions in our tutorials, we look at our voltage divider. The light-dependent resistor, LDR, changes resistance based on how much light is touching the circuit. For instance, if there's a lot of light touching the circuit, or touching the LDR for instance, let's say it goes down to about 1K, 1,000 ohms. That's when a lot of light is hitting it. And since we have a fixed resistor here of about 10K, we'll have about 0.45 volts, roughly, based on this value at our voltage divider line. Now the calculation is very simple. It's RT, our total, so this resistance plus this resistance, and take our VCC divided by RT and then multiply by whatever is on your LDR. Again, I have a very detailed tutorial. It's very simple, easier to follow. Look at the link below. So when a lot of light is hitting the circuit, hitting the LDR, we have about 1K on the LDR, we get about 0.45 volts here, meaning 0.45 volts is yet to be dropped along the LDR, and roughly 4.5 volts is dropped along the 10K ohm resistor. In the case of where darkness is hitting the LDR, we'll get about 100K, roughly, of resistance along the LDR, the light-dependent resistor, in which case the voltage on the voltage divider line, the sense line, is roughly 4.54 volts. Now, these are basic values. They might not be exactly what we see. Depends on how much light is hitting it or how much darkness is hitting it. Anyhow, so this will be our voltage divider line. We also have a simulated voltage divider line here. And what we're going to do is we are going to create 2.5 volts along this variable resistor line. Now, this variable resistor, we can use this wiper to point it anywhere between VCC and ground. So between 0 volts and 5 volts. In this case, VCC is 5 volts. So what we want to do is we want to tune this variable resistor. So what we have to do is take a multimeter, our negative probe, connect that to ground. This is our ground reference point, meaning they are all interconnected. And take our positive lead, our positive probe, place it on the wiper line, which is labeled VAR1 for variable resistor 1, and use the screwdriver to tune that output voltage to 2.5 volts. Now, if you remember our comparative tutorial listed below, we know that if there's more voltage on the positive line than the negative line, the output will be high, meaning the output will be whatever VCC is, 5 volts. In the case where there's more voltage at the negative input than the positive input, then the output will be 0 volts. So what we're going to do here for our first test is we're going to connect our sense line to our positive input, and we're going to connect our variable resistor to our negative input. So I've made those connections, blue for the negative, black for the positive. So we've tuned our variable resistor output to be 2.5 volts. So the input lead on the learning board is labeled CMP1, 1 negative, for comparator 1 negative input. Our positive input is labeled CMP1 plus for comparator 1 positive. So when there's a lot of light hitting the sensor, there should be about 1K on the LDR, meaning there's about 0.45 volts on there. In which case, if there's 0.45 volts on the positive input and 2.5 volts on the negative input, what should the output be? The voltage on the negative input is higher than that on the positive, so the output should be 0 volts. So what we're going to do is we're going to connect our output, labeled CMP1 out for comparator 1 out, to our LED indicator. This is our 390 ohm resistor that limits current to our light emitting diode, or red light emitting diode. So, in the case of when we turn out the lights, there will be darkness hitting the LDR, in which case we'll have a higher resistance, which means we'll see about 4 volts on the sense line, and that means that we'll have 4.5 volts on the positive input, 2.5 volts on the negative. So the voltage on the positive exceeds the voltage on the negative, so the output is high. Our light emitting diode will turn on. However, what if we do this? Let's shake things up. Sorry. So what have we done? We've reversed our operation. Now we've got 2.5 volts on our positive, and now we've got our sense line going to our negative. So in light, 1K will have 0.45 volts on the negative input when there's a lot of light on in the room, and there will be a higher voltage of 2.5 volts on the positive input. So when there's a lot of light hitting the sensor, our output will be high, 5 volts, and our light emitting diode will turn on. And in darkness, 100K, we'll see about 4.54 volts on the sense line, and that's going to the negative input. And so 4.54 volts exceeds our 2.5 volt reference on our negative line. Negative has a higher voltage than our positive. Our output is low. So let's hook this up on our board. First things first, our variable resistor output, our voltage divider, which we're going to set to 2.5 volts, is right here, labeled VAR1. This pin needs to be set to 2.5 volts. This is the tunable 10-turn potentiometer. It's a 100K potentiometer, and that can be the output can be tuned to anywhere between 5 volts and 0 volts, and it's labeled on the board VAR1. So what I need to do is I need to bring in my multimeter. Now I've got my multimeter set to read voltage, so I need to put my positive or my negative probe on the ground line of the board. Now I can do that one of different ways. The 7805, again tutorial below on what the 7805 does, regulates to 5 volts. The top back is actually ground. Or I can use any of the ground lines here. All of the bottom of row here is labeled common for common ground. So what I'm going to do is I'm going to take my multimeter lead and just put it on the 7805. And I'm going to take my positive lead and I'm going to place it on VAR1. That's at 3.19 volts. I want to tune that down to roughly 2.5 volts. Actually, 3.19 would be ideal for this, but we're going to tune it to right in the middle, to 2.5 volts. Now, since I don't have a third hand, I'm going to have to take my hand off here, and I'm going to take my screwdriver, and I'm going to adjust VAR1. I'm going to turn it right a few times. There we go, 2.62. So I'm going to turn it right a few more times, maybe one more, and we should be pretty close. Yeah, good enough, 2.51 volts. So we've calibrated our variable resistor. So now what we need to do is there is a 6-pin header here, up here, that determines whether we're using the vibration sensor, the mic, or the LDR. The leftmost pins are labeled mic, the middle pins are labeled LDR, and the rightmost pins are labeled VIB. Place the 2-pin header on the LDR pins. Okay. So what you can do, this is an optional step. I already know how the light-dependent resistor circuit is going to work. We just went over it. It's got a 10K resistor in series with the LDR circuit, and the sense line is in the middle. Now the sense line is right over here. It's labeled sense on the board. Now there's not a lot of light hitting it right now, but I can have a quick look and read 0.67 volts in light, which is what we expect. We expect the voltage to be much higher in darkness when I cover the LDR. So actually, what you can do is you can actually take your positive lead, place it on the sense line, and see how the voltage changes based on how much light is on your LDR, which is right here, that little orange thing. So, now what we want to do is we want to connect our sense line, which is our LDR circuit, to the positive input of the comparator, of our first comparator. Now our comparator lines are at the bottom here. We want to connect our sense line to our CMP1 positive line. From there, we want to take our calibrated variable resistor output of 2.5 volts, VAR1, and connect it to CMP1 negative, our negative comparator input. There are two comparators on the board, hence the CMP1 and CMP2. Lastly, what we want to do is we want to place our comparator output on our LED block. And so what we'll do is there is a line here at the bottom labeled CMP1 out. Comparator out. Comparator 2 out is right below, but we're not using comparator 2. And our LED block is right here. That's our LED. So what I'm going to do right now is I have my board powered up at 9 volts. It's being regulated down to 5 volts from our 5 volt regulator. Our 5 volts is our VCC. I'm going to go turn out the lights. Pretty neat, huh? So, when we have light on the LDR, we've got roughly 0.45 volts in that area on our sense line, and that's going to our positive input. And we've got a dedicated 2.5 volts on our negative input. So when there's a lot of light on the LDR, there's more voltage on the negative than the positive. And when I turn out the light, the resistance on the LDR goes up, and the voltage on the sense line goes up, and it exceeds 2.5 volts, which is on the negative line. So we get more than 4 volts on the positive line. There's 2.5 volts calibrated on our negative line, so our LED turns on. Again, I'll turn out the lights one more time. Now, what happens if I switch, like we talked about on the board? What if I put my LDR voltage on my negative input and my 2.5 volts from our variable resistor on the positive input? So I've switched around the logic. Now the LED is on when I've got my light on, and if I turn my light off, the LED turns off. So hopefully that makes sense. It's just a matter of placing two different voltages on a comparator. A comparator compares. It's all it does. Output is high or low. Hopefully you've understood this video. If you want to know more about voltage dividers and variable resistors as voltage dividers, comparators, and your LED circuit, please check out the tutorials below. The tutorials are free. The board is up for pre-order. You'll save money. 20 plus projects, and you really get to learn a lot about these blocks and how they work. So it's a lot of fun to play with. Plug and play. All you need to do is put a couple plugins. There are complicated projects, there are simple projects, and really you can take away from it what you want. You can either just enjoy it, piddle around with it, or you can really take stuff home with it. You can really understand how each of these blocks is working. Anyhow, I appreciate your time. Thanks for watching. Check us out at engineeringshock.com, electroniclessons.com, and paintballprops.com.